Hello students, welcome back. Nice to see you. So students, let us start with the next entrance module of the chapter rotational motion. Now in this module students, we are going to discuss MCQs based on the concept of moment of inertia. Now students, if you remember, in the last module, we discussed one MCQ that was based on concept of moment of inertia, yes or no? There we saw four particles kept at the corners of a square. Okay, here also we are going to discuss one MCQ that is based on the concept of moment of inertia. So let us see what is in the store. Okay, so are you geared up? Can we start the module? Fine, let us go on. First, let us take a look at the question. 3 point masses, each of mass 5 kg, are placed at the corners of an equilateral triangle of side 8 meter. The moment of inertia of the system about an axis coinciding with one corner of the triangle is. Okay, what are the options? Option A is 240 kilogram meter square, option B is 480 kilogram meter square, option C is 560 kilogram meter square, and option D is 1000 kilogram meter square. Okay students, now let us solve this MCQ. First, let us identify this question and let us set it up neatly. Okay, fine. See the question students. 3 point masses, each of mass 5 kg. Okay, 3 point masses. Where they are kept? They are placed at the corners of what? Of an equilateral triangle of side 8 meter. Okay, now with this data, I can draw a diagram. Yes or no? You'll get the following diagram. ABC is an equilateral triangle and 3 point masses M1, M2 and M3, they are kept at the corners of the triangle and the side of the triangle is 8 meter. So you will get this diagram. Okay, fine. Let us go back to the question. The moment of inertia of the system about an axis coinciding with one corner of the triangle. So what they are saying is, you need to take an axis and that axis should coincide with one corner of the triangle and you need to find out what is the moment of inertia of this system about that axis. Okay, now that corner can be any corner, any one of the 3 corners of the triangle. So what I'm going to do is, I'm going to take an axis. Now this axis Z, Z dash is coinciding with corner A of the triangle. Okay, now we need to find out what is the moment of inertia of the system about this axis, that is IZ. So we need to calculate what is IZ. Okay students, now which formula can I use over here? Yes, very good, very good. 3 point masses, so immediately moment of inertia of system of particles. We know moment of inertia of system of particles, it is IZ is summation of I is equal to 1 to n MIRI square. So using this formula we can find out what is IZ. So students, the question has been identified and it is beautifully been set up. So can we go and execute and evaluate it? Fine. So let us move on to the execution. First students, see the formula. IZ is summation of I is equal to 1 to n MIRI square. Alright. Now what is R? R is the perpendicular distance of the particle from the axis of rotation. This you should keep it in mind. Okay. Now let us expand that formula. IZ is equal to, now see the first particle. Where is the first particle? First particle is on the axis. So then since the first particle is on the axis, we can say R1 is 0. So then IZ will be M1 into 0 square. Okay, plus. Now, where is the second particle and third particle? Yes, very good. Second particle is at a distance of 8 meter, third particle is at a distance of 8 meter. Wrong. Completely wrong. See there, see this cloud. R is the perpendicular distance of the particle. Is AB and AC perpendicular distance? No. So what is the perpendicular distance? Now see the diagram. I can draw a perpendicular AE. Now AE is perpendicular to BC. Now the length AE BH. Now you see M2 and M3 are at a distance of H from the axis. So H is your perpendicular distance, not 8 meter. AB and AC, they are perpendicular? No, impossible. Okay, so H is perpendicular. So the distance H, that is your perpendicular distance. So now the formula will become IZ is M1 into 0 square plus M2 into H square plus M3 into H square. Why? Because H is the perpendicular distance of these two particles. Alright, so please be very careful students. R is the perpendicular distance. Now students, we have the formula. So can we solve? Hold on. We don't know what is H. So first we need to find out what is H. M2 and M3 is given in the question. Okay, so we need to find out H. For finding H, take a look at the diagram. Here you have a right angle triangle. ABE is a right angle triangle. Now we can find out H. AE is your H. So how to find out H? See there, angle is given 60. So we can say what is sine 60? Sine 60 is Opposite side is your h. Hypotenuse is 8. It is h by 8. We know the value of sine 60. Yes. Sine 60 is root 3 by 2. This is equal to h upon 8. Now you can cancel out. Which term you can cancel? Yes. 2 and 8. 8 will become 4. So now what is h? H will become nothing but it is 4 root 3 meter. So now we have h. So can we find out Iz? Yes. Now we can write Iz is equal to m1 into 0 square will become 0. Now hold on. See that formula. What is common over there? See these two terms? There is a term common. Yes, very good. H square is common. So within bracket you will get m2 plus m3. Now students, we can write Iz is equal to, we know what is h. H is 4 root 3. Also we know what is m2 and m3. m2 and m3 is 5 kg. It's given in the question. So then Iz will be 4 root 3 square is nothing but 48 into m2 plus m3 is 10. So 48 into 10 is nothing but 480 kilogram meter square. So Iz is 480 kilogram meter square. So students, very simple. Please be careful, perpendicular distance. So now, let me bring back the question. Now in the question, which option is the correct one? Yes, option B. Option B is 480 kilogram meter square. So option B is the right answer. Is that clear, students? Again, MCQ which is based on system of particles, moment of inertia of system of particles. Be careful with the perpendicular distance. Is that clear? So I'll catch you up in the next module. Until then, keep working. You can do it. You're born to win. Okay? I'll be back.